Hi, my name's Mike Crozier, and I'm being interviewed by Sam McCall. I'm part of IAG, and we're standing here in Wellington City, which is the capital of New Zealand. I've been living here since 1974. Prior to that, I was in Canada for 4 years, and before that, I was in New Zealand and did my PhD at the University of Otago, which is on the South Island. We're looking at a landscape here that is what you describe as a tectonic landscape and erosional responses as a result of that. So the harbour here itself, we can see perhaps the motorway right below us that's travelling south to north. That is running very close to the Wellington Fault. Now the Wellington Fault is a threat here because it is capable of producing a 7.5 magnitude shake, but fortunately it hasn't moved for about the last 300 years. But if you look in the distance, you'll see a range of mountains called the Rimataka Range, and over other side of that, to the east, there's another fault that threatens Wellington, and that's the Wairarapa Fault. And in 1855, that moved and produced a magnitude 8 earthquake that affected the whole of the Wellington area, and much of that area has been uplifted. This of course has gone on for years, and the streams adjust and start to cut down. The fault line scarp for the Wellington Fault, not the Wairarapa Fault, is just where those cars are running. The actual fault itself is off into the harbour underwater at this point, and the fault block, the fault scarp, has eroded back. Well, it goes back a long way. Mum and Dad were both keen climbers, and all our holidays were spent in the mountains. And all my friends used to go to the beach. But we were in the mountains, and I remember Dad taking me up on a climb. I was 6 years old in a small mountain near Mount Cook, Sebastopol. And amazed me to see these incredible mountains. But what was more important, they weren't just static monuments, because we could hear these rumbles of rock avalanches and ice avalanches taking place. And I could see these glaciers, and they were moving and cutting through the valleys. And I thought, these are processes. It's just not a static environment. That got me really interested in process geomorphology. So those interests, yeah, I had some good teachers, but before I went to university, in the summer before, I found this book by George Jury called The Face of the Earth, and I thought, this is something I can take when I'm away tramping, because it's just a paperback. And I read that from cover to cover, and that was a great stimulus. I then went to university, and I couldn't really make up my mind whether I wanted to do zoology, geology, or physical geography. And I took all those subjects through to stage 3, but I finally went on to geography, the physical geography department, to do my advanced studies. And one of the reasons for that, geology had concentrated mainly on mineralogy and low-grade metamorphics. The only geomorph we had was once a week sitting down, and we all had to read out loud a chapter from Cotton's book and discuss it. Whereas the geography department went on field trips, and that really appealed to me. Right, there are milestones that I guess we all encounter as we go through our careers. And I had become very interested in landslides. In fact, where we lived on the Otago Peninsula, the road was often closed by a big creeping earth flow. Eventually came to include that on my PhD. But I was really impressed by having been sent an article by a geomechanical engineer, a very old article. And this person, Skempton, he in fact was able to explain the evolution of the landscape in valleys that were being created in geomechanical terms. And he was someone that had been involved purely in geomechanics, now translating it into geomorphology. And that was picked up particularly by people at Imperial College. And Carson and Kirkby and Hutchinson all incorporated that into geomorphology. And that to me was one of the great milestones, to be able to explain things in terms of the stresses and the resistance in the processes that we encounter. And those stresses and resistance are very important in understanding lots and lots of geomorphic processes, just not landslides, but sediment transport, bed load transport, glacial movement, and aeolian processes as well. It's very useful to have that basis. The second probably real milestone that developed as I was starting to do research was we were involved in what they call the quantitative revolution. So people stopped just simply describing things. They started measuring whatever they could. And we did measure everything, but we had piles of data and there was not much we could do with it. But with the onset of fast computers, remote imaging and storage devices, we've been able to take advantage of that and develop, for me, developing models where you could then change parameters and test scenarios and different outcomes, which was something that was impossible before that capability. So those are the two main ones. And of course, not affecting me directly, but the sophistication of dating techniques has been tremendous, moving from comparative dating with fossils into carbon dating, and then all the other cosmogenic dating and thermoluminescence and so on, has been a tremendous benefit in working out the rates and evolution of landforms. I'd come back from Canada in 1974 to New Zealand, and 4 years later there was a huge landslide in Peru that affected Yungay, the city of Yungay, Huascaran, and it came down from the Cordillera Blanca, and I really wanted to go there. So I knew I wasn't eligible for leave at that time, but I spent the next two years learning Spanish because I wanted to go there. First year I learned introductory Spanish. Second year I learned introductory Spanish. So I finally got there, and the thing that moved me was the magnitude of this process and the fact that it had been carrying on as episodes from time to time, affecting populations. And the town of Yungay that was hit by this huge rock avalanche from Huascaran, the highest peak in the Andes, was totally buried. I remember walking over there and seeing the roofs of houses, and there was a school bus that had been totally upturned, and the bodies were still in it. And you could just simply see the chassis of that. And yet, 4 years after that avalanche, when I was there, people were moving back to the same sites because they simply had no option. And again, that sort of made me realize if I could apply some of my geomorphology to the issues that humans faced, that would be something I'd like to aim for. The big book that came out under the aegis of IAG on the evolution of geomorphology, a massive tome and a wonderful piece of work. It surprised me, one, that I got a mention in it, but also it called me an applied geologist. And I wasn't quite sure whether I liked that, because, some people said if you can't do geomorphology, you apply it. But in time I began to realize, well, yeah, that's what I want to do. I want to apply my understanding of things to issues that are important to the livelihood of people, their lives and their resources. Yeah. Yeah, just briefly, of course, I've listed a number of books which I think are really worth reading, and papers. The first one was the original paper by Skempton, which started to apply geomechanics to geomorphic problems. And lead on from that a number of other books. Carson and Kirkley is an excellent book that has taken that work on. There are others. I was always impressed by the concepts that Stan Schum came up with in terms of complex responses and the whole notion of thresholds. And one of these things was important. We tended to think to get a process moving, we had to have an impact from a force, and they were external forces, whether it was rainfall or earthquake shaking. But the concept of internal forces, which simply must, like the big avalanche we had on Mount Cook, it wasn't actually triggered by an earthquake. It did create an earthquake, but it was a deterioration of strength and resistance over time, and then suddenly you got this movement. So those concepts are important. The other one I would mention is, as I will talk about, the importance of relating to other disciplines, conjoint disciplines, and I've always been impressed by the linkage between geomorphology and some of the biological sciences. And I have mentioned a paper there by Crozier and others who have used their understanding of the genetic clock in terms of how a species will change through time. And this has been used in a situation in New Zealand and probably many other parts of the world where an anticline has grown and has split a river into two parts. And of course we see the result. You've now got a beheaded river on both sides of this anticline. When did that happen? Well, the fish stock in those rivers, in fact, their mitochondrial DNA changes through time, and there's a known rate for that. So the date of separation between the two fish populations on either side of that anticline can be worked out from that basis. So I think those sorts of things, it's not very precise yet, but a very useful result of combining with other conjoint disciplines. Well, asked to think about what advice I'd give to young geomorphologists, and I've alluded to the fact that I think making contact with other disciplines and listening to where they're at and contributing to their issues is very important. And I've, in my career, I've belonged to the Geomechanics Society, the Earthquake Engineering Society, Geographical Society, and the Hydrological Society. It's always found something of interest in that. So that mixture of disciplines is worthwhile. One of my leaves was, in fact, to US Department of Agriculture Forest Research Station in Cornwallis, and I was dealing with people from other disciplines but working on the same sort of landslide problems, and so it's always useful to do that. The other thing I would say, a piece of advice, is to get a mentor, and I was very fortunate to have Dennis Brunsden as a mentor when he came out from King's College to New Zealand, and I took him out to see the earth flow I was working on the Otago Peninsula, and he was always receptive to giving me advice as to how I should tackle that problem. And I remember receiving foolscap pages handwritten from him every month or so as I was working through my PhD, and that was very useful, yeah. Okay, the IAG, I've got to be careful what I say here, of course. It's been, for me, it has been fantastic. And it takes, how did I get involved in it? Well, it goes back to my mentor again, Dennis Brunsden. And I attended perhaps the third conference that was ever run, and he insisted that I should put myself up and for the committee, and I did. But the beauty of that has meant that with various meetings of that committee, I got to meet a lot of fellow young geomorphologists at that time, and particularly in Germany at Heidelberg University. Dietrich Barsch was there, had a number of young students, and he encouraged me to work with them, and I did over the years. And one group of students, led by Richard Dekel, got the position at Bonn University, and again, so I spent a lot of time with them at Bonn. And other students from Heidelberg I visited in subsequent years as a visiting professor at Jena in Germany. And that has benefited my career tremendously. And so IAG does focus on helping younger geomorphologists as well as helping people from less developed countries. And I think in that respect, they're doing a very good job. Well, yeah, the New Zealand, as we've seen over the years, has become often known, and I think it's a reasonable statement to say it's the geomorphic laboratory of the world. A lot of people want to come here, and many have, and in a sense the IAG links has helped a lot of people to discover the fantastic landscape we have here. But yes, we are living at the bottom of the world in a raft, and working on my PhD, I didn't have at that stage very many links, except for Professor Dennis Brunsden's influence. And when I finished my PhD, the last year of my PhD, I got a job at the lowest possible status you could get in the university, which was a junior lecturer. But not only that, it was a temporary junior lecturer. But then I applied to go overseas, and I was applied to one or two places as a postdoc, and I applied also to our University of Alberta in Canada. And they said, oh, we can give you a postdoc, but why don't you come as an assistant professor, and we'll give you your first year salary without tax, which I thought was very good. But it was at that time that I realized I met other people. We had people from the lecturers at that university. We had a huge first-year class of 900 students broken up between a number of professors, and discussing what we were going to do. I realized that even though I came from a raft in the South Pacific, I actually knew as much as these guys did that had been at Oxford, Cambridge, Reading, and other universities. So I thought, well, the university system in New Zealand can't be all that bad. But it was a lovely affirmation that, in fact, it gave me a chance to see the world, and it also it was an affirmation that the training in this country is pretty good. Yeah. Well, Wellington is clearly a very rugged landscape, full of hills and valleys, and surrounded by mountains. And what we're looking at here is probably the highest hill around the Wellington CBD, and you can see a tower on top of it. That's Mount Coco, and it's very important in the history of geomorphology. Sir Charles Cotton, who was a geomorphologist and at the Victoria University of Wellington for many, many years, but most of his work was done in the 1920s, he interpreted this landscape very much in a Divisian terms. He saw that it was a very broken and rugged landscape, but that many parts of it were sort of isolated and deeply weathered promontories, and he considered these to be part of a marine pronation surface, or at least an erosional surface. In Divisian terms, it would have been called a peneplain at one time, that has now been broken by faulted, uplifted, cut down by fluvial erosion, but still leaving relatively flat portions of this old surface now high above sea level. And he referred to this as the K surface. And some people think it was named after Mount Coco because he used that as one of the remnants of the old peneplain surface. But if you read his literature, the K stood for a key datum in understanding the landscape. Well, the question came up, does geomorphology have a future, I guess, as a coherent study, as a discipline? And we're always asking these things. And what are the threats to it? Well, first of all, in terms of the real problems today in our landscape, you know, forced by climate change, the flooding, landslides, all these issues, on top of the other issues of the Anthropocene, that's burgeoning populations, we've really got lots of hazards and issues that we need to study and understand, and it's changing all the time. And this is well suited to process studies in geomorphology. So yes, there's a real reason for us to exist. Will we? Well, like many other broad subjects, in fact, you think of geography. Geography split into physical and human geography. Physical geography has been split into tectonic geomorphology, fluvial geomorphology, periglacial geomorphology, and so on. So it's easy to become myopic and just simply cluster around people of our own disciplines. But I think it's still important that those people that are contributing, maybe in dating or in some issues like that, they come together to look at the big picture from time to time. So yes, geomorphology, I think, has a role, and it should keep going. This is probably the most important. Get away from your computer, get out and see it. See the geomorphology out in the bush. And don't linger. Do that tomorrow.